So thanks a lot for inviting me. And as Vittorio said, this is a kind of short overview of some of the activities we did about the use of data for the conservation, valorization, and even creation of artworks. Most of this work has been possible also thanks to the activity of Professor Chiara Potrioli, that today is not here, and also in my case, this activity is now carried on also in a spin-off named WSense of Sapienza University of Rome. Okay, first of all, conservation. What we did. Basically, we developed a system made of sensors that can be placed both on the artworks and on the box hosting the artworks that measure the stresses, mostly mechanical stresses, but also measure on temperature and humidity while during the transportation of those artworks, and will provide a report in order to guarantee the safety of the transport, but also B, in order to possibly collect a sufficiently large amount of data in order to be the perfect box for the transportation. This activity has been carried on with the MIBACT, which is the Ministry of Cultural Heritage and Activities and Tourism. And just to give you a rough idea, in 2015, when we started this activity, about 6,000 state artworks have been transported. So it's a big, a big market for Italy in particular, and a need in order to guarantee the safety of something that is usually of extreme value. This is a rough idea of what we do. This is the Pietà Rondanini by Michelangelo. And as you see, there are those tiny sensors, the white boxes on the left side, that are placed both on the artworks and on the box. And during the transportation, we collect all the data, and then we can provide a detailed report on what has been basically what happened during the transportation again. We did a lot of work in order to improve the system, to improve the energy efficiency, in order to guarantee longer transports, in order to reduce the size and the weight, because in some cases those sensors are also placed on canvas, and that is extremely important to reduce both the size and the weight. And now we have, I would say, a first product, and we are now experimenting with a new release that is big as a coin of €2, say the logic, and then we have the sensor on the canvas. Again, also in this case, we have both, I would say, conservation and valorization, but in a very specific domain. Here we are talking about underwater sensor network. So in particular, this is the focus of WSense, the development of the Internet of Underwater Things. Why is this again related with artworks? Because basically, according to the Archeomar project survey, in Italy there are more than 1,000 underwater archaeological sites offshore. And so you can imagine how much are in the Mediterranean basin. And again, according to the UNESCO Convention for the Protection of the Underwater Cultural Heritage, there is a recommendation for in situ conservation. So the question is how to build a system capable to protect those sites and at the same time valorize the sites and provide the right tool for the conservation. Here the challenge is that now I would say that terrestrial communication are kind of commodity. We know that there is a very high bandwidth and a very good reliability. All those, say, aspects are not true in the underwater domain. Because the radio frequency does not work, so you need acoustic communication. This implies that you have a very high latency, a significantly reduced data rate. Furthermore, as you can see in this picture, you have mobile nodes namely scuba and unmanned autonomous underwater vehicles that move. And so our solution in order to improve the reliability of the links is to implement a network solution with multiple paths, which allows you to significantly improve the reliability and also the performance of the system. For what purpose? In the case of artworks, as you see in the picture on the top, we have a kind of tablet for scuba that can go underwater in order to collect data, and also we started an activity for 3D image reconstruction using underwater images. Now, this is particularly interesting because thanks to the AUV, we can now dynamically and in real-time control the vehicles in order to implement specific plans. Notice that up to now, this is not possible in most of the cases. Namely, AUV vehicles get the plan when they are on the surface, then they implement the plan, and they come back to the surface in order to download the data. Thanks to the network infrastructure, you can basically get in touch with the AUV during the during the execution of the plan. Okay, those are examples of our equipment. As you see, the modem is the white box with the tablet, and this can be whereby scuba on the top left, top right picture, and an example on the top left picture of our system with the modem and some sensors. In that case, are sensors about pollution and temperature, and also for the acoustic localization of underwater vehicles. In particular, now we are involved in the ArcheoSub project. This activity has been supported significantly by the Sunrise project, and now we are involved in this ArcheoSub project for the conservation of underwater sites here in Italy. Finally, I would say a kind of hobby. So this is the creation of from data. The idea is to transform data into 3D objects. Basically, you can get any kind of data source. It's a kind of artistic process. It's for fun. As an example, in the picture on the top left, you have a picture from Gapminder, in which that relates the income of population with the life expectancy. So then you can map those data in a 3D shape, and an example is the ones that is represented here on the top right, and then you can print it and possible wear it. Okay? This has been done in is publicly available in Instructables. Is a site which allows you to follow step by step the process in order to explore the process. That's it. There is a video, but I do like more questions, and possibly when see the video later on if you are interested.
Okay, thanks a lot.